Hello everyone. In this lecture we are going to learn about Introduction to Pressure Vessel Design in PVElite. Our flagship courses are Master Static Equipment Design and PVElite, ASME Section 8 Division 2, and Master Welded Storage Tank, as per API 650. We have curated courses to suit your learning needs. So do visit our learning platform for more details on scootoid.thinkific.com.
What are the different software which are available in the market for doing pressure vessel design? So the first starting point will be this thing, like what exactly we discussed just now. What are the different softwares available? Because I have listed few of them which I'm mostly aware of. So compress, autopipe, PVElite, you already know, and we are here for PVElite, so we'll talk about that. But let us try to see what are the other softwares. We also have a design cal. That is also one software which is available. We have pass equip. That is also one software which is there. Then inspect. That is mainly for in-service inspection. 579 purpose, mainly API 579. Okay. And then many of you which you already mentioned, like VVD, okay, code, MPVD. So we have multiple software, okay, but among them, PVElite and compress are very widely used. Okay. In India, if you ask, around 90% of people use PVElite. Okay. So now that is what we are going to see today. So very basic and intro kind of thing. We're not going to go deep into the software because definitely in 1 hour, we cannot do justice. Great. So PVElite, okay, that is what we are going to discuss today. Now, do you guys aware that what are the different codes which we can design by using PVElite? What are the different codes? In all this software are catering to multiple different codes. Okay, few of them can cater to multiple. Few of them are meant for particular code. Okay. So what do you think about PVElite? What are the different codes which are there? Division 1, Division 2, EN 13445, and PD50. So these are the documents. These are the codes which normally are referred by PVElite. So PVElite is one software which caters to multiple codes. Okay, that is the biggest advantage of PVElite. And it comes with the same license. Okay. The basic license which is given, with that all these codes are inbuilt. Okay. So that is the biggest advantage. Okay. So ASME Section 8 Division 1. Okay. ASME Section 8 Division 2, we have class 1 option also, and you have option for class 2 also. Okay. Then we have PD 5500 and EN 13444. So all these design codes are inbuilt in PVElite. Okay. So it's a very, very comprehensive software which takes care of many things. Okay. Now, what is the difference between analysis and design by rule? What exactly is the basic difference when we use analysis word? So analysis, if you see in very simple terms, so in analysis, what you'll do, you will provide all the dimensions of that component which you want to design. So you'll be assuming the thickness, okay, for all the part, you'll be giving the material. Okay. So complete model you'll be making, and then you'll be providing the load, and then you'll be analyzing whether that part is able to take that load or not. Making sense? So you will be assuming the thickness. That from there it will start. Okay. You're not calculating the thickness based on the loading. You're assuming the thickness, giving the load, and then finding the stresses and deformation, whatever. So analysis is a bigger term. Many times we relate with finite element analysis. So yes, finite element analysis is part of it, and it's easier to relate with that because that is what we use most of the time. Okay. As an analysis tool. So analysis, in very simple words, assuming the thickness, giving the property, apply the load, and getting the result. Okay. Now that result further may need processing. Okay. You may not be able to directly, by seeing the result, may give the decision. Okay. Most of the time, a few times, that there is again analysis which can give you direct results also. So the method of analysis are different. Okay. But majority of time, what analysis we do, there we need to perform lots of post processing. Okay. We need to compare, classify the stresses, compare with the allowable. Okay. So that is analysis. What is tool for manual calculation? Like hand calculation. Okay. Like the calculation which you do in Excel sheet. Okay. That is a calculation. Okay. So PVElite is nothing but a hand calculation. Okay. It's a tool which will simplify your calculation. Somebody is making an Excel sheet on your behalf. Does that make sense? Now, why then they are selling it if it is just an Excel sheet? Why so many people are using it and why that cost is so high? Why everybody cannot make it? What will be the justification? If it is an Excel sheet, if you put some hours, we can definitely make this kind of software. Okay. So learning software itself is a big task. Do you agree? I'm talking about analysis. If you have to learn analysis, the learning software and mastering that software itself is a big challenge. Do you agree with that? Okay. So you have to learn both the things, like code you're learning, and then you're learning the software. It's a skill which you keep on building. So after 2-3 years of experience, you might say that, okay, I have a good hold on that. Whether the same thing is true for design by calculation softwares like PVElite, is that same thing true? That you need lot many hours you need to put before learning it? Whether it is as difficult as, if you just compare with ANSYS. Okay. So how you'll rate learning ANSYS? In learning ANSYS, you need to first learn how to prepare sketches, that 2D drawing, then how you make model with that 3D, then how you do the meshing part. Okay. So lots of things, every activity is many hours you need to learn each and every step. Okay. And then forget about the post processing and all. Okay. While these softwares are designed by calculation, it is much easier to use if you practice a little bit very easily, like 2-3 months. If you are focused, you can definitely get a hold of it. It's a tool. Okay. So don't think that just learning the software will solve your problem. There are two things which you need to learn. One is the software mastery, and second is the code mastery. Once you grow in your career, software part will be lesser important, and the code knowledge will become more important thing for you. Okay. Because wherever PVElite is giving error or warnings, you need to relate with code and try to justify. So it's very important. So I hope you got some clarity about what is PVElite. Make sense? So it's a very simple tool. I always say it like, club of Excel sheet. So now I was asking one question. I think that discussion left in between, that if, why not, every organization is preparing their own Excel sheet and using it. Why to buy this software? Does it make sense to buy? And we also not only to purchase, but every year, even after you have the perpetual license, you have to pay the maintenance. Okay, that is also a good chunk. So why not to use an Excel sheet? What is the limitation? why we are going for this software? Can you think of a logic? Okay. Even if you don't know, you might think in terms of logic. First, let us start with one point. Okay. Like why client is asking for a software. If I'm using an Excel sheet, don't you think it will be difficult for me each year to update that software? Agree that updating that Excel sheet, okay, each and every year will be very difficult. Okay, I have to hold that person who has built it. Okay, because if there are multiple people editing, that cannot be reliable. So it has to be restricted. And if you are restricting and only one person is changing it, okay, or updating, to retaining that person becomes topmost priority. Okay, because the next person, then it will be very difficult to hold. Okay, and the second point, which validation. Who will validate your calculation? Every time when I submit my calculation to the client, it will be a challenge for him. Make sense, guys? Every time when I submit that calculation, he will not only have to check all the inputs, but also each and every step. He'll sit with the calculator and he has to check each and every step. True or not? Do you think it's true? Are you able to get the real challenge? Okay. Why? Even though it would have been a very simple Excel sheet. Okay. It is always easier if one organization is taking care of it. Okay, and all the others are accepting that. Make sense? Even though it might would have been very simple software. Okay. Then also, will love somebody to take care of it, which is agreed by everyone, and everybody will use the same Excel sheet. Okay. And nobody will be able to change any calculation, just the input part. Right? Then only it will be usable. Otherwise, it will be always troublesome for the reviewer. Okay. Very difficult job. Okay. So that is where this standard softwares comes into picture. Okay. Now, again, one question related to this. Now we'll be involving code also. Now, if I'm using PVElite software, am I responsible for the accuracy of that software or not? Or the PVElite company is responsible? Who is responsible? All said and done. That we need trust and somebody else is taking care. But who is responsible when I'm submitting that report to someone? Still, you are responsible. Note that. Okay, it's not that the responsibility has gone away. It's just the trust. Okay, so client understands that what exactly you can do in the software. Getting the point, right? Clients also understand what exactly you can do, what is there in your control. So he'll be at least checking that part only. Okay. So which is inbuilt in software, even if there is a fault, he understands that that is a fault by the software. Okay. So now his scope again becomes less for checking part. If he is able to check the inputs, he understands that output will be correct. Okay. So it's very important. Still, even though software are there, you are the responsible person. Okay. It is written in code, right? Do you agree that it is written in code? Okay. So in forward, it is written. Okay. So it's a very important point. Okay. So now you understand what is PVElite. Next part. Okay. So now we'll just try to go in the software and try to see, what exactly that software is. Okay. So are you ready to dive deep into the software? So we are going to keep it very simple. Okay. And then you'll also see that it is much easier to learn this software. Okay. Much easier compared to, uh, other software which you might be using, even compared with AutoCAD. Okay. So if you ask my personal experience, and I have not seen any software much easier than this to use. Okay. So very easy. Now, let us, if I have to create a shell, okay, what do you think where I should go to create? You can see the uh, elements, you can see the accessories of it. Okay. Yeah. So where I need to go? Elements. Okay. So I have just entered here and I can create a cylindrical shell. Very simple, right? Now there are, you can see the heads, elliptical head if I want to add, if I want to add a tori sphere, hemisphere, flat head, okay, cone, and then I have a flange, skirt also is there. Okay. Then we have clamp connection. This is a new addition. Okay. How many of you are aware of this? Clamp connection. Very new. Okay. Which is very recently added. Even this rectangular vessel, it's a new addition. It was there in CodeCal, which is again part of PVElite. But these two things, clamp connection and this rectangular, is very recently added. Okay. So earlier we used to have only these many tabs. Okay. So now I have added a shell just by clicking. I have not uh, given any other command, just added a shell. Okay. Now, if I have added shell, let us give a name of it, element description. So I'll just call it as a shell. Okay. Let us call it as a shell. Now we have from node, we have to node. Okay. That means from where it will start and where it will go. So it could have been anything, like A, B, C, D also. Okay. So just PVElite has selected 10, 20, 30, 40. So it's just to indicate the sequence of the elements, nothing else. Okay. Then you have elements, which now if I want to change this, even though I have inserted a cylindrical shell, if I want to change, I can change it from here. But recently I don't want to do that. Now you can see the diameter is in inches. If you are not comfortable, okay, or your project is requiring SI, then you'll go to the units. You can see on the right hand side, and then you will select SI ASME. Okay, this is the important selection which you need to do. So ASME I'll follow because I want ASME units to come. Okay. So now I want to provide ID because cylinders or shells are designed based on ID. So let us assume one diameter 2000. So automatically the shape has been taken. Now the length of the cylinder, let us say it's 3000 length cylinder. Thickness, can I input the thickness now? Can I input the thickness now? We have two thicknesses, finished and nominal. No. Okay. Why no? Because I have not entered any design data. Okay. So after adding the design data, I can think of giving the thickness, right? So let us skip both internal finished and nominal thickness. Both I'll skip, and then directly I'll go to the corrosion allowance. So internal corrosion allowance, normally it is 3 Let us take 3 Now external corrosion, do I need to provide external corrosion allowance? Most of the time it is not there. Okay, because outside is painted and maintained, so you don't need corrosion allowance most of the time. Okay. Now you may have some design where externally also corrosion allowance is given, possible. What about wind dia multiplier? What exactly it is? What is wind dia multiplier? 20% design margin in wind area. Okay. So when you are designing this component for wind, the area which is calculated for this vessel, 20% additional margin will be taken. Why? Why that is required? Why the 20% you need to put as a margin? because you'll be having nozzles. Okay. So you will be having nozzles, which area is not calculated. Okay. So attachments, which area is not calculated in the software. So even though it is modeled, area will not be calculated for wind. Okay. So to take care of all that, you multiply with 20%. Okay. Now, if you're adding platforms, that in platforms, you have option for area. So that definitely that area, you can provide it there for platform. So for platform, it is not required, but for nozzles and other attachments, you need to have. Okay. Material, let us say I have 516 grade 70. If it is not there, I can just write name like 516. Then also you'll be able to see the chart and you can find 51670. So you have different grades. So here it is B31.3. So you don't select that. You will selecting this 516. Okay, not A. We need ASME, SA. So this is what I'll be selecting. Okay. Select. Okay. Now, if I select normalized or quench, I'll be getting better impact properties. Okay. So you can start with not normalized and then you can select. So let us go with normalized. Okay. Now SIM efficiency. If it is from pipe, you select pipe specification, SA106. Still, you won't be selecting that option, A. Even though it is made from pipe, the code is ASME. Okay, so you'll be designing with ASME, not B31.3. Make sense? So now moving to the longitudinal SIM efficiency. Okay. So just select this. Okay. If you want to have the detail. Okay. Now, on what condition this efficiency depends? Can you tell me on which things your efficiency depends? The efficiency of, see, now these are the things where you need code awareness. Okay. So unless you need ASME code, otherwise you'll be just inputting the data if you don't know ASME. Okay. So if you go here, you have multiple options, UW12. So depending upon two things, one is the weld joint type and the second radiography requirements. Okay, so both combinedly decide what should be your efficiency. Okay, so now let us select full radiography as per UW11 type 1. So if I select that, I'll be getting joint efficiency as 1. So I'll be selecting for both long sim and sur sim. Okay. Now for longitudinal weld sim, you may have multiple long sim if your diameter is very large. Do you agree with that statement? That you'll be having multiple long sims if your diameter is very large. Okay, because in one plate, rolling, you won't be able to cover the full circumference, right? Like this, you can see in the sketch. So if your diameter is big, in 2000 diameter, we can manage with one long sim, right? So let us keep the number 1. Now, where you want to keep that orientation, let us keep at 45 degree. Okay. And keep the other, because there are no other sims, I'll put 0, 0. Okay. So apply changes. So you can see the long sim is now indicated at 45 degree. Okay. And say okay. So now you can see one long sim which is there in this direction. Okay. 45 degree. Okay. So there you can change the angles of it. Okay. Now pressure. Okay. So what exactly is the pressure that you'll be providing? Internal design pressure? Let us take it as 2 MPa. Okay. Temperature, let us take 250. External pressure will be 0.1, which is atmospheric. Okay. Temperature, let us keep at 100. So this is the input which you need to provide. Now you can see the thicknesses. What will be the shell length? Shell length is based on the plate width which you are getting. It cannot be more than the plate width which can get in the market. Okay, so that is what you have to take in the model also. Make sense? So if you're having a 3-meter width plate, then you can have a length of 3 meter. If you're using 2.4, 2.5, use that. If you're using 1.8 meter width, we'll be using that. So now you can see the thickness required here. Okay. So what is the required thickness, guys? Now this part, even if you are very new, you can relate, right? T required means internal pressure design thickness. Okay. And T required external, it's already written external here. So 17.67 is the minimum thickness required. Okay. Whether this is including corrosion allowance or excluding, whether this is including corrosion allowance. Okay. So you don't have to add. So 17.67 is the design thickness. Okay. Now, what finished thickness I should give? Now I'll come to the thickness and change that thickness. What finished thickness I should give? What is the finished thickness I should give? Finished I'm talking about. Akash. Now, in the shell, it's very important for you to understand that when you form, okay, shell from a plate, it's basically a rolling operation. Okay, it's not forming. So in rolling, you don't have change in thickness. Okay, if you start with 18 mm, 18 mm is what will remain. Okay, so we'll be selecting 18 as a finished and 18 as a nominal, both. Okay, so do I need to consider mill tolerance? Okay, so many times people get confused with this. So as per mill, 0.3 mm under tolerance will be there. So if you purchase 18 mm, you'll be getting mill tolerance. Okay. But do I need to consider mill tolerance here or not? What is your opinion? Mill under tolerance. Like if you're procuring 18 mm plate, you'll be getting, see, plate manufacturer also needs tolerance, right? 18 mm does not mean anything in physical world. Okay. We need tolerance to make anything, right? So it'll be under tolerance, like 0.3 mm under tolerance for plate. That is the permissible limit. Plus, you can go up to based on the thicknesses, plus 2 mm also. Okay. So for different thicknesses and width of the plate, it is different. So minus 0.3 is the under tolerance. Okay. So now, if I get 18 mm plate, what minimum I'll get? What minimum thickness you'll be getting with 18 mm? 17.7. Okay. So do I need to get worried? No, right? My thickness is still lower. Now, what if this thickness would have been 17.8? What if the required thickness would have been 17.8? Can I take 18 mm plate or not? See, now again, we are going into code. So these things are you able to relate now? Okay. So PVElite is not different from ASME. For each and every step, you need these kind of things, engineering judgment, which comes from the code. So 18 mm, can I take? So in ASME, if you are getting confused, just read UG 16. Okay. So if the difference between these two, okay, means whatever minimum you are getting, so 18 minus 3, so 17.7. Okay. So the difference between 17.7 and the required, okay, if it is less than 0.3, then you can use that plate. Okay. So under tolerance, you don't need to add for plates. Okay. Now The same philosophy. For pipe, it is different. Remember this point, guys. Okay. Now, this may be going into little bit depth for some of you who are very new to this, but almost 50% of you who are familiar, so that for them it makes sense. Do you guys understanding what I'm trying to say? For plate, you don't need to bother about under tolerance. Okay, because 0.3 mm, we don't go beyond that. Okay, so you'll be able to anyway meet that. Okay, so there won't be any issue. But when we talk about pipe, then you have to add the under tolerance and then select the schedule. Okay, so that is difference between when you design from pipe. Yeah, 12.5% Gumala, absolutely right. Okay, so when you see the calculation of PVElite also, you will find that. Great. So if it makes sense, very good. Not, does not matter. Okay. We may be, when we talk about in some other, in ASME, when we discuss, then maybe we can discuss. So now we have provided all the input. Okay. But I don't want a vertical vessel. I want a horizontal vessel. Then definitely there must be some provision. Okay. So I'll be going to utility. Utility is having options to, like if you want to insert something, delete something, rotate. Okay. So you can see that symbol, flip. Okay. So just use that and it is flipped. Now this job is horizontal. Okay. Now I want to add one descent. Okay. So let me add a elliptical descent. Okay. I want elliptical descent at the end. So I've just selected and you can see the descent is getting added. Okay. But it is getting added after my shell, right? I need before and also, right? I need at left hand side. Then what I can do? So if I select and keep on adding, it will be added right hand side. Okay. So remember, when you make models in PVElite, you should always make it from left hand to right hand side. Don't start with right hand component and then move to the left hand, because then every time you need to use additional tab, which is insert. Okay, you don't want to use it for everything. You want the normal flow. So normal flow is left to right. And if you are making vertical, then if you select pipe MOC, it will not calculate. Okay, only if the component is piping, then only it will. So for nozzle, it calculates. Okay, so in that case, you need to add. So for vertical, what we should do? For vertical, bottom to top, that is the normal direction. So you should make in that. Okay, so now I have created a shell. Okay, I should have started with a descent. So now if I forgot I want to add, then I'll select this shell before which I need to add that element, and then I'll go to insert. Okay, by using normal elements I won't be able to add. Okay, so I'll be using insert, then I'll be adding, and then I want to add an elliptical and before. Okay, so I'll select that. Now I have a ellipsoidal. Okay, so now see the description of this. It has taken from the previous descriptions shell. Okay, which is not correct. Okay, so I'll write left head. Okay, we need to write a proper description. Why we need to have the proper description? So that when you see in the calculation, you can identify that part. Okay, flange length, I'll be keeping straight face length 50 mm. Okay, I'll not touch the thickness now. Let me just complete that details. So material name and everything. See now, once you have entered all this detail for the first element, for next element, the data is already taken care. Okay, you can see the pressure, temperature, everything is exactly same what you have entered. Okay, so that is taken care. Now you see what is the T required is 17.51. Now what finished thickness I'll take? What is the finished thickness which you should take? 18. Shall I go with 18? So 18 is what I'll take. Okay. Still, I have some margin, which I'll keep that in my pocket. What about nominal? If finished is 18, what about nominal? For nominal, you need to add the forming allowance. Okay. Normally, you can take 10% as a thinning. Like if you want more guidance, where it is available, some guidance where you can use that as a reference. Dennis Moss. Okay. So Dennis Moss, it is available. So see that table. Okay. So let us, for now, let us use 20. And so nothing else I need to change. Now I'll take the right head. Okay. Then 50 is the straight face, finished 80 and nominal 20. Okay. So now my design is done. Okay. Now for some reason, okay, let us say you have multiple elements. Okay. You have a very large horizontal vessel. Okay. And you have multiple elements. If you have to change the data, if you have very long elements, like a column, if it is there, where there are multiple shell elements, okay. If you have to change a data, let us say that pressure itself, little bit you want to change. You might be doing some iteration and you want to change that. So what approach you'll follow? Whether you have to change it in every element, you can go to design constraint. What if I have to change a material? If I have to change a material for all the elements, then do I need to go with each element? Okay, let us say there are 20 different elements. There are 19 shells and 2 heads. So should I go and change the material in each and every element independently, or there is any shortcut available? Where you'll go, you have a utility. Okay, in that you have a sharing information tab. See that? Sharing information. Okay, the element from which you data want to copy, change in that element and then select it. Okay, and copy till that element which you want change to reflect. Okay, so in one go, all the elements will be changed. A quick hack for some of you might be already using, some of you might not be knowing, right? So how many, like if you have done multiple changes, you might have done multiple changes. Okay, you want to copy the same change in all the elements, just use the share information. Okay, and select whatever you want to update. Okay, and every element that will change. Okay, that is a good thing which you have to use, may have to use multiple times. Okay, great. So now I have made that vessel. Now I want to add some static head, okay, into it. So I'll select here. You can see in detail. Okay, so now anything additional on the element will be provided in the detail tab. Okay, main element will be coming into the elements. Anything like a tab which is helpful for orientation and sharing information, that will be finding in utility. Okay. Now any attachment which you want to take, okay, like insulation, okay, you have lining, you have water or any liquid, okay, platforms, nozzles. Okay, so all that you have to take it from details tab. Okay, that is kind of auxiliary to the element. Okay, making sense to everyone? Is it making sense? Yeah. So now I'll just add, let us take water as an element. Okay, water does not need any distance, so I'll keep it 0. I need specific gravity, 1 I'll provide. Okay, now what will happen if I use this tab full? What will happen if I use this tab? it will fill the water in the descent, which left hand. The completely it will fill the water, or it will fill the water in all the elements with full. So remember, whatever element you have selected, okay, whatever element you have selected here, that first element which is left head is selected. Okay, so if I select that and give a command full, now that descent will be completely full. Okay, only that descent. If I want to give particular height, then I can mention here. I want liquid at only up to 1800. Okay, I'll say okay. So now you can see water is filled up to 1800. Okay, now what if I want to fill the complete elements all at the same time? Then I'll be using this one. Okay, fill elements now, and you'll be having all the elements which are filled together. Okay, make sense, guys? You don't have to enter each and every element. You can just fill with one command. Okay, at a particular level, because horizontal, it's the easiest way to fill. Okay, but remember then the description does not copied. Okay, when you use that command description, you can see for first one it has taken water which we had given. For the second and third, it has used liquid 20, liquid 30. Okay. So now if you don't want to use that, then you can select that element and change. So that you'll have to do individually. Okay, for all the elements you have to go and change it. Okay, this may be a flaw part of PVElite, because if description is given, it should give description to all. It does not make sense that different services will not be there, right, in different elements. Now we have filled the water. Okay, now what next? What you want to do next? Support, saddle support. Do you want to have a saddle support? Yeah, so let us design a saddle support. Okay, so for saddle support, nozzle also will take, don't worry. For horizontal, we will not be able to make skirt. So we'll go with saddle. We will be making nozzle also, don't worry. Okay, so select a shell where you need the saddle, and then select the option of saddle here. Okay, you can see the saddle. So select the saddle. Now either you can fill that complete data, or you can select a saddle from MOS. Okay, whatever data has been given in MOS and in MM. So straight away, your all the data has been filled as per Dennis MOS data. Okay, now I'll go to add a new saddle. You need at least 2 saddles, right? So you'll go add a new saddle, and you'll say the same as first. Okay, see how quickly you got the saddle. Okay, now you can run the calculation. If something is failing, you can try to optimize it or increase the thickness. Make sense? In Dennis Moss, there is a for if you go to the saddle design, there is a data given like how what dimensions you should select for standard. Okay. Even in EL, you'll find. Okay, EL standard many people follow. So if you want that, you can use, and there are multiple which you can use. Okay, you can also, there is Excel sheet. Okay, so that you can use. See, so you can see the data which is already filled. Okay, based on the size of. Okay, it's very similar to what you have in EIL. Okay, so I say okay, and then you have saddles which are there. Okay, now my job will be much easier. Okay. So see how quickly you are able to make it. Okay. Now I want to add one nozzle. Let us go and add one nozzle. Okay. I want a nozzle with RF pad. Okay. Set in nozzle with RF pad. So I'll be selecting first one. If I want set on, then I'll be using the second one. Okay. Set on with RF pad, then fourth one. Okay. These are the nozzles with lip type. And these are self-reinforced nozzles. So different types of nozzles I can make. Okay. So I'm using the first one where nozzle with RF pad. Okay. Let us call it as nozzle N1. 106 grade B is what I want to use. Okay. Now in nozzle data, remember that. Okay. Your design basis will be what? ID, or it should be OD when you are selecting a standard pipe. What do you think your diameter basis will be? What I should keep the diameter basis? Always it is OD basis, right? For piping, you remember. What about the thickness basis? What about thickness basis which you should keep when you are selecting pipe? You'll be always selecting minimum. Okay, you select the minimum. See, first you select the size. Okay, now even before selecting size, okay, let us say this actual option is there. Okay, then even you won't be able to select the size. Getting it, guys? So very time you may find that, okay, why I'm not able to select the size? Why? Because there is actual written. Okay, so either you have nominal or minimum, then only you'll be able to see the selection of the size. Okay, so start with here, and then you go and select. Okay. Yes, for pipe you select minimum. If you are making for plate, then you'll be selecting actual. Okay, so these are the two which we use. Okay, minimum. Okay, so in this case, so 6 inches. Now so this is not passing. Okay, it's failing in UG 45. That means what? What I need to do? If the failure is in UG 45, if you are aware with code, you can tell what we do for this case. Increase the thickness. Okay, increase the thickness. Very good. Okay, so means increasing the schedule will increase the thickness. So 80, still not. What next? So I'll go to 120. Okay, so at 120 it is passing. Okay. So that will be my selection. Okay, now where it is located? Okay, so let us say it's located in the center of the shell. So 1500 is the right thing. Layout. Okay. If you have already set the layout before starting that model, then you are aware of what exactly layout you are having. Okay. If not, then you take any orientation and then see what exactly. Now, for setting the layout, what is normally preferred? You select north. Okay. Now, where do we set that setting? Anybody can tell me how we get this setting? Whether 0 degree is top or at what location? How do we set that? Let us go with that in configuration. Okay. So I'll just say okay because I'll have to close it and then I'll go to configuration. Okay. I'll go to default values. Okay. Now in default values, okay, if you're using old editions, this may look very different. Okay, because in 26 edition they have changed that the layout. So you can see here default 0. You can have it in east, west. Okay, so normally we keep it in north, and then rotation clockwise. So we have clockwise rotation and this in north. Then it means 0 degree is at top. Make sense, guys? Now I'll come back to this. Now I know 0 degree is my north. So I want at the top, so it's okay. I want 200 projection, so I'll update that. Now I can see that flange rating is failing. Okay, so I can increase the flange rating from here. So I'll make 300. Now it is meeting. So I'll say okay. My nozzle is placed, okay, at the top. RF pad here, that you can see this is the place for RF pad. Okay, so just keep the thickness of the RF pad equal to the shell thickness and diameter as twice that opening. Okay, and you'll be good to go. Okay, you'll be also able to see what is the area required and area provided. Okay, so if you want if you're asking about flange, then yes, 16.47 is what you use for more than 24-inch. If you're asking here, okay, then you have to create that, okay, by using a nominal, without using this option and giving the actual size. Insert plate, okay, you can see you can increase the thickness of that local part. Okay, you can see that effective thickness, local shell thickness. If you increase here, that acts as a insert plate. So this is how you create. Okay, now if you want to add insulation, okay, let us say you want to add insulation for the complete vessel, just select this, okay, and then you provide that insulation. Okay, you just need to write the thickness of it and the density. Okay, so normally we take 120 if you are taking mineral wool, 120 kg per meter cube. So here it will be, like 1.6. Okay, it's not taking that calculation, so I need to input, okay, 0.12. Okay, that is what it will be. So now if I just say full, I've selected the shell. If I just say full and say okay, you can see the insulation is only on the particular element. Okay, if I say all instead of full, you can see whatever elements you have model in one go, it will be covered with insulation. Okay, how many of you have used that option? Many of you might not be using it. Okay, so that is a quick method. Okay, now many times once you add insulation, it becomes difficult to use that model, right? Because if anytime I'm clicking a double click, you'll be getting that insulation data. Okay, so you don't want to have that. Then what you'll do, you'll go to visibility and then you can unselect that insulation. Okay, then insulation is there, it is model, but now you won't be able to see it. Okay, now if you again want to see it, you can select that. Okay, so you can do with all the description all. If you don't want to see this description, you want to have a clean model, maybe for image purpose you are taking, then you can go here and in visibility you can remove all that. Okay, just a right click, and then you have the option. Yeah, so insulation, a similar lining also you can have. Okay, if you want to have a ladder platform, that also you can make. Okay, so here you are not designing that ladder or the platform, but just providing the weight and also the area for wind and seismic calculation. Okay, that is what you are having here. Okay, so I'll not model it. So I'll just close the demo till here. Okay,
For in-depth training and to learn more about these courses, register with the link in the description.